And welcome back to this week's video about infrared items. As you can see, I've got on my desk this little credit card size transmitter, takes a 2032 battery, and this little tiny keys receiver module, which is in fact a Vishay VS1838B, but really this could be any of those receivers that receive only on a particular wavelength. Namely, this is a 38 kilohertz receiver. Now your television remote is probably pretty much the same, so I thought I'd give it a whirl and just see if this would solve a problem that I've had for a little while. What's that problem, you ask? Well, in the discussions on my channel on and off, I've been talking about real-time clocks and whether or not we can get the real-time clock adjusted easily without having to sort of muck about with buttons or plug it into a NTP server, that's a network time protocol server, or whatever it is we're trying to do to keep that real-time clock up to date. And I think I've cracked it now, or at least I've got a mechanism for doing it. That means I won't have to use up multiple pins on my Arduino or Nano trying to connect up all the switches. Even if I was to go to a real simplistic solution of just a couple of switches, A, it's a little bit clunky to use, that is, and B, still uses 2 pins, whereas this, of course, only uses 1, and it's a delight to use because you've got all these possible permutations on here. Now, the library that comes with this unit, actually, this is a keys unit, is quite good. Well, I'll say quite good, that's damning it with faint praise, isn't it? It's very good, and you can use it to send out infrared pulses as well, not using this same transistor here. This is a receiver, but if you connect it up to a transmitter, then it will send it out with the right protocol. Protocol, I hear you ask, what do I mean? Well, each manufacturer, you know, Sony, Samsung, NEC, I don't know, JVC, all these manufacturers use a particular sequence of numbers on their infrared. So, well, I'm not sure whether they do it so they don't interfere with each other, or whether it's just some sort of proprietary protocol they've decided to use, but they all use slightly different ones. And the library that comes with this deals with them all, but it actually works for all the transmitters that I've got. I've got some here scattered around the back of my desk, which you can see here, and we'll be playing about with those. In just a minute. Right. So let's have a look at where I got this unit from first, because I think if you thought, oh, I might play with this, if I told you this was going to cost £20 or $25, you probably might think again, but luckily for us, nothing like it. So here it is. Now I bought these from Chips Fans, as you can see. I bought from this chap or woman or company, whatever it is, many times before. They're either 99 pence each or 2 for 184, so I couldn't resist that sort of bargain, so I bought 2. Now for that you do get the actual remote control transmitter, right, nice lightweight. You do get the actual receiver, and you get, as it shows you in the picture there, the actual cables to connect up. Now it's only 3 wires, that's positive 5 volts, ground, and your actual signal wire. So the signal wire, I think on this one goes into pin 11 at the moment. That's what the example library showed. So for that sort of price, I thought, what can I use it for? And I've had these around for a little while, and it dawned on me a week or 2 back, this is what I need to be able to set a real-time clock. 1 pin with just some business logic, if you like, behind the scenes. So let's have a look at the very, very simple raw code that tells you what sort of signal is coming down the wire, and we can display that very easily using our standard Arduino IDE. So here's the very simple sketch. Now the library that we're using is the IR remote library. So it only uses 1 pin, as it says here, look, pin 11. Set up the object to take in the receiver data and declare a variable for the results. Start up the actual receiver. Blink 13 means do you want the LED to blink, a bit like on the TV, you know, when you press a remote button, it flashes a few times, so it flashes, although it must be said that on this, where is it, on this unit here, this also has a built-in LED and that will also flash. But it's a good little thing to have. You can either set it true or false. In fact, I had a look at the library underneath. I think you can probably change that LED if you hack the library. So what do? We say, well, if we've got something to display, that is, we have detected something, then we're going to have a look at what type it is. That is, type as in protocol, as in manufacturer. And as you can see here, look, it looks at whether it's an NEC, Sony, RC5, RC6, not sure about that. There's a few more. I think in fact this is a slightly curtailed list, because if you look at the actual library underneath, there are many, many more manufacturers. Anyway, if it doesn't know what it is, it prints unknown. But I think, as I say, that's just because this sample sketch is particularly brief. And it puts the output in hex. So let's just have a quick look at that running. I'll fire up the debug window, aka serial monitor. So what we need to do now is point this at it. So if I press the number 1, for example, there we are. So it says NEC FF6897, and then I'll notice that after the correct value has been given out, it then prints out all these Fs. I don't know whether that's deliberate from the transmitter here, or whether it's, I don't know, some kind of end of transmission. But if you hold your button on, you just get a string of these Fs. So if I press the number 2, for example, so that's what happens. Like, you still get all these Fs printed out after the value. So it might almost be used as a confirmation, like until it does get a string of Fs, it won't take the value you've actually pressed. In fact, if you've ever noticed that with your TV, sometimes you do have to press the button for slightly longer than you might think you ought to have to. So a very quick blip isn't enough to change channels. You do have to hold your finger down on that button for a little bit. Some transmitters, I think it might be Sony, have to transmit things 3 times before they're accepted. So that's just, this is, I mean, this actual device, it says it's NEC, it's obviously using the NEC protocol, and that's fine. So a couple of unknowns there. That means probably bounced a signal off somewhere else. So if I point this at the ceiling, there's lots of lights here because I've got my video lights on and everything. Let's see if it can actually receive anything at all. No, it's too much for it. And of course, this is pointing down here, isn't it? So I'll do this. I'll hold this device way back here. So I'll press the number 5. There we are. Look, 6. Yeah, I mean that's another unknown. So it's receiving it fine. So that's that one. Now I've got a Sony one here. What's this for? Oh, this is for my clock radio. So let's see what it does with this. Press a couple of buttons. There we are. Sony, it says. That's great. It's a bit disconcerting to see all these unknowns afterwards, but that's just seems to be the way it works. I don't know why. And what else have I got? Okay, I've got one here that controls my bathroom heater. So let's press that. Oh, that's an NEC as well. NEC seems to be used quite a lot, doesn't it? What's this? Well, this is a Samsung TV remote control. So let's press the up volume on this. Oh, nothing. Okay, let's press a number. Oh, the number works, but, well, I say it works. So Samsung doesn't work then, because although the actual device is flashing, let me just bring it onto the workbench. So if I press this here, look, you can see it flashing down here, and indeed on the unit here. So it is actually doing something, but oh, that's it. Aha! Now look at that side, isn't it? It suddenly sprung into life. But it still says unknown. But I think it's saying unknown because that sketch hasn't looked at all the possible permutations, all the possible protocols. And finally then, just to prove the point, what have we got here? We've got a, well, I don't know what this is for. Oh, this is for my Digibox. So it is in fact a totally alien device, really. And once again, look, it's the NEC protocol. Now that's fine. So all right, so you're thinking, all right, Ralph, so you've proven the point. We can get one of these 99p combination units and get some kind of hex value out. How's that really going to apply in the real world to an Arduino project? Okay, let me show you my next sketch that takes this information and makes it a little bit more real world, and something that I'll certainly be taking forward for my real-time clock. Right, let me just get that. I'm actually going to use the Sublime text editor for this rather than the Arduino. And the reason I'm not using my Eclipse one is because I upgraded from version 3 to version 4. And yep, you've guessed it, it's sort of partially broken, quite frankly. So a little bit irritating, that, to say the least. So let me get the Sublime text editor up and we'll see what it looks like there. Right, here's the Sublime text editor, and if you haven't seen this text editor before, I must recommend that you watch my video about this, because it is that step up from the Arduino IDE, not least because it's got IntelliSense and the color coding is better. But anyway, let's fire up the serial monitor, which on here, what do? We go to Arduino, which you can't see, it's off screen. Don't know what hasn't captured that. Anyway, we go to Arduino, serial monitor, run, and there we are. What we get is an error message because we've got the standard IDE running as well. So let me shut that one down, and it says setup complete. Now the only anomaly I've found so far with this Sublime text editor is you do get these sort of CR, carriage return symbols on screen. Now there is in fact an add-on or plug-in or whatever you want to call it, a package that you can add that's supposed to stop that, but I've not actually got that to work yet either, so I'll just put up with it for now. Okay, let's upload this sketch then to the Arduino. In fact, I'll tell you what I'm going to do. I'm going to put this onto full browser mode so that you can actually see what's happening behind the scenes, because otherwise you can't see the toolbar and all its messages. It's just the way the screen capture is obviously working. Right, here we are then. So this is now looking at the monitor rather than the window. So now you can see this toolbar at the top. So to upload this, it's all plugged into COM5, that's fine. So Arduino and upload. We've already done the verify compile, so upload, and off it goes. I'm starting uploading. It says it's actually gone off the bottom of the screen, so you still can't see it all. Right, it's done uploading. So let's look at the serial monitor again and just see what's coming out there. So setup complete, it says. I'm just going to restart this. Arduino, serial monitor, run. And right, setup complete. Great. So now we use the standard remote control that came with it, and we just press number 1. Oh, and it says number 1, that's handy. Number 2? Okay, let's try something a little bit more complicated, like the left arrow. It's a bit, you can't really see the, in fact I can't even see them in real life really, but there is a sort of black left symbol on there, so let's try that. Oh, it says left, that's good. Right, yes. What about down? Okay, here's a difficult one, the OK button in the middle. Oh, it says OK as well, that's brilliant. So then we got the full number range here, 0, 9, 8, 9, whatever, star, yep, great, hash, yep, hash. So that's it. So what we've actually done here, very simply, is translate all those hex values that are coming out here into something a bit more meaningful that we could potentially use in an Arduino sketch. Now, all right, we wouldn't want necessarily the full word left, right, down and OK and all that, but you'd interpret these yourself within the sketch. So you might have L, R, D, U for up, and then OK might be I don't know, a -1 or something, however you want to interpret it. But the point being that we could, as an example, take my example that I want to use this for. We have a DS3231 real-time clock running, and now we want to set that time. So the obvious thing would be to, in the Arduino sketch, say, okay, give me the value that you want to set it to. Well, obviously we can type in the numbers now on this device and then move right to the next field. So, you know, day, month, year, hour, minutes, and so on. And then just press OK, and it will take all that and send those values then to the DS3231 real-time clock. And all it's going to take is 1 pin. And yet we've got the advantage, the massive advantage in my view, of a full gamut of keys to press to make it very, very quick and easy to actually set the values correctly and easily without using up all the pins on the Arduino, because obviously the pins on Arduino are precious and far too few. And it also means, of course, you don't have to have buttons sticking out your project, do you? That means you can, all you need is this little infrared thing, and you wouldn't necessarily use this on a module. You might have buy this actual infrared receiver separately and mount it sort of somewhere behind a little red piece of plastic or something, or maybe just poking out the top. But the point being that you haven't got anything sticking out the front of your project, whatever that is, and in fact your project could be mounted in an otherwise inaccessible place, because this has got a range, it says, of up to 8 meters. We'll have a look at the spec sheets and all that in just a while. So let's have a look at this sketch. It's really simple. So it's the same as last time, except here I've put in all the codes, these hex codes that come out of here, all the buttons, that is, and I've said, well, these translate into these ones here, 1 through 0, and the star and the hash, up, down, all that. And just in my code here, we say, right, go and get the value, and then in this little bit here, we just whiz round in a loop, saying find that hex value if you can, and if you can, take the equivalent from the other array. So what we're actually doing is going through this array. It's a string array, as you can see, one by one, to see if we can find a match, and if we can, so we take the equivalent one here. So if we go, the real one is here, so this is the fourth one across. That would be the index value of 3, so we start from 0, 1, 2, 3, and go 0, 1, 2, 3, and there's the number 4. Easy peasy. So you can make that slightly more sophisticated, of course, and as I say, you wouldn't necessarily want the actual words here. You'd probably want some kind of value that you then interpret in your Arduino code. Brilliant. Now I reckon that's a real cheap but yet sophisticated way of doing it. I mean, 99 pence or 2 for 187. I think it's really worth exploring. And more to the point, it stops us having to reinvent the wheel, doesn't it? And have buttons all over the place just to change the time, maybe once or twice a year, or I don't know, if it starts getting out of step, maybe 2 or 3 times a year. But as I say, the DS3231 real-time clock, in my experience, is extremely accurate, and it's temperature controlled, which is why I always recommend it over other ones. And of course, it then means I don't really need to use an Ethernet shield or anything like that for getting the time from a network time protocol server, nor do I have to get the time from a GPS, which I still want to experiment with, but that's a different video altogether. Right, let's have a look at some of the information that we can find on this unit, because I think although spec sheets seem a bit dry, they are actually packed full of all the information you need to make your project a success. So let's do that next. Right, here we are back at the browser. So these are the items that I bought, and of course there's dozens of these on eBay. Whichever part of the world you're in, you can probably find these. So let's just work our way through the tabs on this particular one. So this is the library that I'm using, Arduino IR Remote. There's probably more out there, and as I say, the actual underlying library has more protocols available to it than is being shown in that sketch. So it's worth experimenting. Right. This is the little infrared receiver module PDF. So basically that describes this little thing here, which is the same as that one down there. It's a VS1838B, as I say, and the others will probably work just as well. But the good thing about this is that it is an IC. It's not just an LED, it's a proper IC, all encapsulated to reject spurious infrared like sunlight or anything, and it works on a carrier frequency of 38 kilohertz, which is pretty standard. There might be some infrared at 36 kilohertz, but I think all the ones that I've tested here, I think they're all 38 kilohertz. So it does all that sort of rejection of spurious IR to give you a clean, nice signal in most situations. So that's pretty good. You can buy these. Well, they're extremely cheap actually. Right, so that's that, and this is the PDF for it. There's loads of stuff in here that you can see. It is of course 5 volt friendly, 2.7 to 5.5, so you can use that anything from a 3.3 to a 5. That's brilliant. Now it says here actually the frequency is 37.9 kilohertz. All right, I don't know why it's not 38 kilohertz, to be quite honest. Receiving distance 18 meters. I haven't tested that, I must admit. I did do it from over the other side of the office here, and that was probably about 3 meters tops. That was enough for me. But 18, well, under perfect conditions, I'm sure that's true. As I say, 3 wires, ground, VCC and out on that one. That's the signal. This board actually that I've got here is slightly different to that picture, but it has got the signal on the right hand side. Let's just go back to full screen. As you can see there, look, the signal slightly blurred. There we are. Signal is on the right, the power's in the middle, and the ground is on the left. So it is pretty much the same. Right, okay, that's enough of that. I'll put links of that. Oh, here's a little demo thing as well, actually. I think mine was a little bit different to that, but there are. Okay, so I'll put that a link. All these pages will have links at the bottom of the video description. Right, what else have I got here? That's, yes, this is a bit more about, well, okay, it says AX1838, and I can't really tell the difference between an AX38 and a VS1838, apart from the fact they're obviously manufactured by different factories. So this is an Axin, I don't know if you say it like that, do you say Axin or an Axin or whatever, and the other one was a Vishay, VISHAY, so it just tells you a bit more about it. Oh, it tells you about high immunity against ambient light, which is in fact important. If you've got sunlight on this, it could be important that it rejects that. Okay, a few parameters and stuff. I'll leave that for you to browse. What else have we got here? Oh, that's something entirely different I was going to talk about, but I think we might be running out of time now. Now, this is the joystick that I was telling you about, that I was sort of half thinking about using instead of one of these. It's not quite the one I wanted, because this has got potentiometers here and here. So you've got an X and a Y as an analog. Now, of course, you can easily convert that analog value into a digital, so it's either on or not without any intermediate value. But once again, look how many pins we need. You see, it's just too many, isn't it? And then, of course, you've got all the faffing about with the conversion, whereas this, you've got all these values, including the left, right, up and down, which is all this can do, let's face it. Oh, and it's got a center click, okay, which is a bit like having the OK button. But I'm thinking, yeah, this is good in its own place. If you perhaps want to, if you do want an analog value like speed control of a motor for a robot arm or a car or something, that's great. But for what I want, it's this. All right, I'll quickly tell you about that other thing then. So somebody on my channel, and I won't name names, you know who you are, thanks very much for letting me know. I was talking about MOSFETs. When we drive things from an Arduino, you must have a gate level MOSFET. That is to say, you must be able to drive it fully on with 5 volts, which is what you get out of an Arduino. And I was moaning a bit, but that MOSFETs generally are quite expensive. Now, normally I'd use these, and in fact have used these. I've actually been on it 5 volt gate. Now these are fine, and these weren't too expensive either. These are an RFP 12N 10L. They're pretty good. On resistance, that's drain to source, on resistance is 0.2 ohms, which is not bad, quite frankly, not bad at all. Until I discovered these, or I didn't discover, I was pointed to these. Now these are an IRL Z44N. You get 10 pieces for £1.31, which is probably about $1.50, something like that. So that's pretty cheap, isn't it? And you think, well, what am I getting for my value here? Well, first of all, it is a gate level MOSFET. Let's have a look at the spec here. So for a start, the very first thing it says is logic level gate drive. Brilliant, you go. That's exactly what I want, and they're cheap. What's the on resistance? Well, look, once again over here, they're making a big song and a dance about the fact it's 0.022 ohms. So this is like an absolute no-brainer. This is the MOSFET for Arduino people to use. Do not use anything that does not have a logic level gate drive. And with this sort of 55 volts, 47 amps, not at the same time, I must admit, and that on resistance, this is the one to use. I don't know what the power dissipation. So the maximum power at 25 watts, at 25 degrees, is 110 watts. Well, you probably need some kind of heatsink at that point. But if you work out the power dissipation now with a 0.022 ohm resistance, you could probably put quite a few amps through this at sort of Arduino type voltages, 12 volts or something like that, before you needed a heatsink. So I just thought I'd throw that in as a little extra because I was quite excited to get these. And I bought 2 sets, so they come in little strips like this. And where did I buy them from? Oh yes, it was AliExpress actually. Who's the seller? It was store Survey 2014. Anyway, he's a top rated seller, it says, and they came pretty quick. And for that price, look, 14 pence a piece. No brainer. It's cheaper than standard NPN bipolar transistor, isn't it? Brilliant. Okay, I just thought I'd throw that in there if we had time. We haven't, but I said it anyway. So what we are talking about is these. I reckon that's a really good, cheap way of implementing lots of button functions. And of course, I'm going to use this for a real-time clock, but I bet you've got 1,000 different ideas on what this could be used for those occasional things where you don't really want buttons sticking out of your project box, control panel, what have you. And it's simple and easy to do. And I'll put that sketch that I put together, nicely commented, at the bottom of this video as per normal. Great stuff. Right, let's call a halt to there. Today, that's it. It's a nice quick video. I say that every time, don't I? It never is. Okay, thanks very much for watching and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.